Hi, hello to everyone. This is Dr. Satheesh Kumar, working as Associate Professor in the Department of Information Technology at the Institute of Aeronautical Engineering, Hyderabad. So, in this section, just we are going to see about the optimal decision in games and what is the MINMAX algorithm in artificial intelligence. Just everyone knows that we are having some set of problem solving in a real world approaches. Okay, just we are using some artificial intelligence technique to find the maximum solution based on your knowledge base. So in this way, today just we are going to discuss about what is the optimal decision in games. Okay, just while you are playing a game such as a chess, 8-pin problem, 4-pin problems, some traveling problems, some shortest path of finding, etc. Just in the games, just we are going to making some problematic approaches and how the min-max algorithm is going to be approaches in this special topic in artificial intelligence. Just you will learn. Okay, so in that, just in the overview of this section is what is the exact concept of the optimal decision in games using artificial intelligence machines, and how the min-max algorithm will work in the particular or a specific problem statement. The basic concept just I will tell you, and definition also, and with an example just I will explain the all the methods in artificial intelligence. And then first just we will see what is optimal decision. Okay, so what is the optimal? The first just what is mean by the optimal means just we are going to find some appropriate solution for the given problem statement. Okay, just we having some problem statement for the related the problem statement. Just we are going to gather some inputs, related inputs to find the some optimum solution. Right. So here that we are going to take some decision to solve some set of problems. Okay, then methods, some way of performances we are going to analyze this based on your collected inputs and based on your knowledge base. Okay, so here the optimal search provides an action sequencing ending in a winning terminal state. Okay, so the optimal solution is nothing but finally just we are going to produce some solution or predict some solution based on your problem statement. Okay, so here the optimal decision means of the final stage, just winning stage, we are going to take some decision based on your different algorithm or based on your knowledge base. So that is the concept of the optimal decision in games. While we are going design one game, and we are in that design, just we are going to give some set of inputs and set of procedures and the code of ethics and the code of winning state or goal state. The thing that we are going to design, right? That way, just we are going to analyze the some set of optimal decision in the artificial intelligence. Okay, so here, so in this search, just we are going to use a min and max method to design the game or playing the game in artificial intelligence. Okay, so min has an impact of this search. Okay, that the minimum method that we are going to use as impact in your the searching technique. Okay, here the response max find the consequent strategies. Okay, the max will find the set of procedures we have to follow, and predicted output also just we have to follow in the optimal solution. Okay, so this is the what optimal decision in games in artificial intelligence. So exactly what is this? What is the min and the max? How it will be obtained to solve some particular problems in artificial intelligence, we will see. So max picks in initial move. Okay, so we have a setup. For example, just we have one tree, some game tree. Just consider this is a game tree. Okay, so here, so what is the first max picks an initial move. Okay, so this one is a max. Okay, So then comes up with a move in the response to every minimum counter move. So then second one is here the minimum move. Okay, so always the parent node is as a maximum node, the next one is a minimum node, the next one is the maximum node, as well as just it will go to up to the depth search. Okay, so here exactly just we are going to use some depth first search algorithm and backtracking algorithm. Just I will tell you while I'm telling that MINMAX algorithms. Okay, so this is a basic concept. So if you consider this is a gaming tree, the first root node. Okay, the initial move it will start from the max. Okay, then a minimum, then max. And like this, exactly just it will going to be considered to read all the nodes in your gaming tree. Okay, so basically the max is anticipating the move, all minimum counter moves and maximum counter moves, etc. Okay, so I said right here first is we have to consider the maximum and the max counter. The next one just we have to consider the minimum counter. Okay, so this way just we are going to consider in the optimal decision. Then analogous to the and or search algorithm. Okay, in the way of electronics and communication, just we are going to set that and or operations, especially in the gaming tree. Okay, here the maximum is going to be considered or. Okay, then minimum is going to be considered as and. Okay, so this way the and or algorithm will work in the decision optimal decision, right? So here see here the minimum is and. Okay, the maximum is or, then a minimum is and. Okay, like this just we are going to consider while you are designing the games tree in your problem statement. Okay, so think of it way the option is strategy provide outcome at least you good any opponent. Okay, so just we are going to play in a game. Okay, just we have some opponent. Okay, that opponent also they have to follow the same procedure, same algorithm as max is or minimum and. Okay, so find the optimal strategy using the min-max value from each node, and this is the we are going to use. Okay, the use function is a min-max of n. Okay, so totally how many nodes are present in your gaming tree, just we are going to take it as the min-max. Okay, the next one is the value assumes both players play optimally in the entire game. Okay, so both the players, opponent players or both opponent players, just they have to play in optimally in the entire game. They have to consider the first root node is a max, the next node is a minimum to find all the strategies. Okay, the min-max value of a terminal state is just its utility. Okay, so for example, here while I'm telling that min-max algorithm, so what is the terminals and what are the utility values are present based on your terminals? This I will explain you. Okay, so here next one is the max refer to move for a maximum value. Okay, so that one node when is the maximum will come, that maximum value of your child node we have to consider the root node value. Okay, the utility value, that is utility value. So minimum frequency move for a minimum value. When we are going to tell that a minimum nodes, that time just we have to consider we have to compute the minimum value, right? So when I'm telling that example, just I will explain you clearly. Okay, so after this say the tune. Okay, the next one is the main reasons. Okay, so what are the reasons we are going to use behind the optimal decision while you are computing or while you are designing a game for playing in real world problems. Okay, so it provides structural task in which you very easy measure the success or failure. Okay, so if you are using the min and max in optimal decision, just we can easily predict the cases will be the success or one or failure one. Okay, that does not require a large amount of knowledge. Okay, for these no need of any knowledge. When only we need some terminals and utility. Okay, so based on that, just we are going to find the nodes value based on your min and maximum algorithms. Okay, here we don't need to enough knowledge to compute the node values. Okay, they are solvable through the straightforward search from the starting state update of the winning position. Okay, already said, just first we are going to apply some depth first search algorithm, as well as after that we are going to apply some backtracking method to calculate or compute all the nodes value based on your min-max procedure. Okay, so but 2 or 3 are not true for any the simplest game. Okay, so what is 2 and 3 is not true. Okay, because we are going to use the depth first search and the backtracking analysis with the like some conditions. Okay, the minimum and the maximum procedure, right? Okay, the next one is the program that simply does not straightforward. Such a game tree will not able to the select even the first move during the lifetime of its opponent. Okay, so we consider the from the top of the node, from the move to the bottom, or we are going to find some optimal solution or finding some value of the node. It will consider from the first move only. Okay, so some kind of a heuristic search procedure is necessary. Okay, here so we have consider some root node values. Here we have to do some heuristic search value, that is a minimum or maximum value should be present over the all the nodes from the down to top. Okay, it is a backtracking. So these are the main reasons just we are going to use while listening the games using the optimal decision in artificial intelligence. Okay, so the next we will see the min-max algorithm. So okay, what is the min-max algorithm? Just we are going to find the values of each and every nodes present in the design tree or a normal tree. Here we are going to use the two procedures, right? One is from the root node to bottom node, that is depth first search just you are going to use. Then from calculating all the value using based on your min-max concepts, we are going to use some backtracking. Okay, the backtracking method just we are going to apply here. Okay, so that is the concept of the min-max search algorithm. Okay, here the min-max algorithm is recursively or backtracking algorithm. Especially, it's very important. Okay, especially in the min-max algorithm, just we are going to use the backtracking algorithm or backtracking method to calculate the node value of based on your min-max concepts. Okay, which is used to decision making and game theory. Okay, so based on this game theory or decision making concepts, restoring all the values based on your min-max concepts. Okay, it provides an optimal move for the player, assuming that opponent is also playing optimally. Okay, this is the optimal strategy. Okay, already said if you are playing, your opponent also they have to follow the same procedure. Then only the full playing the game will fulfill, and we are going to identify all the nodes value. Finally we are going to predict the and the solution is success or failure. Okay. The next one is a min-max algorithm is mostly used for game playing like chess, checkers, tic-tac-toe, etc. Okay, in AA, just if you are using the AA, we are going to design some games that just we are going to use the min-max algorithm. Whatever maybe just you are going to design games in using artificial intelligence, their min-max algorithm will be the participated in the major role. Okay, so this algorithm computes the min-max decision for the corresponding moves. Okay, so always just we are going to follow some min-max procedure to move the left and right or top to bottom using the depth search or backtracking or the algorithm in playing the games or any kind of games. Okay, so this is the min-max search algorithm. Especially just we are going to use in the optimal decision in artificial intelligence to design the some games. Okay, so the next one, some example. Just I'm going to tell one example how we are going to play or how we are going to find the min-max in each and every nodes. Okay, so the next one is make use of a backtracking algorithm. So the benchmark, the backbone of your min-max algorithm is the first is depth first search and the second one is the backtracking algorithm. So based on this technique, based on this method only, just we are going to find each and every node values here. Okay, so the best move strategy is used here. The best move strategy we are going to use. Okay, there is a heuristic based on the heuristic search. Just we are going to move the one place to another places. Okay, for example, just we are going to move from root node to the last node using the depth first search. So depth first search concept from top to, from down to moving to the next forwards, we are using the backtracking. Backtracking method just we are going to use to calculate each and every node values using the min-max concept. Okay, the next one is the max will try to maximize the utility. Okay, there is a best move. Okay, the maximum, just if you are using the max method to move to one place to another place, it will tell us the best move. Okay, the minimum will try to minimize the utility. That is the worst move. Okay, so this way just we are going to use the some functionality in your the min-max algorithm using this in the games. Okay, so see here, just see here, I have this one is a terminal. This one is a terminals. This value is a utility. Okay, so these two things just you have to keep in your mind. Okay, so here this while here is a game tree. Okay, so this one is the game tree. Okay, from this the root node is always considering the first to move. Okay, just previously I said that the first to move always based on your maximum. Okay, so here this maximum just value we have to fix for the root node. So the next node is a minimum. Okay, the next node is a maximum. Okay, like this, first maximum, next minimum, next maximum, then a minimum. So like this as well as just we have to fix the min and max concepts in your all the presented node. Okay, so here just we are going to use some depth first search algorithm to move to root node to some utility node. This is values. Okay, so now we are using some backtracking method to calculate the value of node D. Okay, so the D is, what is the D? Just a maximum. See here, so the this concept of is a maximum. So just we are going to consider the maximum value of this D. Okay, so the 8. See here, 8 is here the maximum value based on you have to compare the both the utility values, right? Or both the terminal values. Okay, -1 and 8. Which one is the maximum? 8. So we have to fix the value of node D is 8. The next one just we have to move to here to the parallel nodes E. Okay, so D is what? Then E. So we have to compare the both the terminals -3, -1. Now just we have to consider the maximum value. The -1 is the maximum value of node E. Okay, now we have to find the node B value. Okay, so node B under the minimum the concept. Okay, so here the node B had to take the value of the minimum one. Then here the what is the minimum one? The -1 is the minimum. So the node B value is -1. Okay, then as well as just we have to move to after completion of this one, just we have to move to the parallel node C. Okay, so from here from C, just here we have to use the same depth first search algorithm. Okay, so from C root node we have to come to the some terminals here. Okay, to find the next value of F. So we have to see the what is the F value, the maximum. What is the concept of F? The maximum value. So from here, what is the maximum value? 2. So the 2 is the maximum value of node F, as well as G. So what is the maximum value? 4. So 4 is the node value of G. The next one is a minimum. So 2 is the minimum value of this one. Then here come. Then we have to come to the root node. Okay, again here just we are going to use the backtracking concepts from this node, second node to the root node. Okay, the root node here just we have to compare. Okay, -1 and C. So what is the concept of the root node is a maximum. So we have to find the maximum value. So which one is the maximum value? 2. So here 2 is the maximum value of your root node. So this way just we are going to use this technique to find all the node value based on your different terminals and utility. Clear? The next one is the drawback again min-max evaluation. Okay, there is a drawback of your min-max algorithm. Okay, so here just I have said that all the procedure how to we are going to find all the values of based on your min-max concepts using the depth first search and backtracking concepts. Okay, so here what is the drawback? The main drawback is traverse every node, both optimal and non-optimal. Okay, so we have to travel each and every node are present in this tree. Okay, there is no other way. Okay, so just we have to find the root node value from down to bottom using the person using the backtracking concept. We have to visit each and every nodes. Okay, we can't omit, we can't neglect or any nodes from trees. Okay, so if it is so, the computational cost of your space complexity, time complexity, we have to calculate. Okay, so the computational cost, the phase complexity is more, memory required, because we have to visit each and every node present over your tree. Okay, the next one is the time complexity is more. Okay, because the same thing, the same reason. So you have to visit each and every node. What are the nodes are present in your tree? We have to visit each and every node. So if it is so, time and space is more, right? So this way, just we are going to find, or we are going to compute the value of your presented nodes in your tree based on your MINMAX algorithm, right? So these are the textbooks, there's some reference books and the web references just I have used to collect all the information related to the optimal addition in games and the MINMAX algorithm. Okay, just be having any doubt how to find the find the value of each and every node you use the MINMAX algorithm in optimal decision in games. Okay, if you have any doubt, just you post in the comment box, just I will clarify. Okay, so just until the seeing the new concept. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.